Hello, everyone. We are Team TechMaster. I'm Haina, one of the developers in this team. I'm glad to introduce you to our project, TechScrum. Next page, please. Yeah. TechScrum is a project management platform whose core users are small to medium-sized software development teams. Its project value is an agile software that prevents delays, which means users can manage their projects from start to finish. This platform allows users to track their projects in a board view and manage ongoing projects and tasks. The project manager can also review individual performance on their assigned tasks. With over 3 months of development, the TechScrum system has finished the second phase. The main features we have completed were the backlog and sprint page, daily Scrum section, and also careers page. And we also updated UI design. In addition to development of new functionality, there were a lot of legacy tech debt and code quality issues generated in the first phase of development. We have addressed those issues to enable developers to work more efficiently and deliver features fast in the future. To be more specific, in the backlog page, users can create tasks of various types, update the priority, status, assignee, and reporter. And users can also delete the task if they no longer need it. Meanwhile, users can also create a sprint, add some tasks from the backlog to that sprint, customize that sprint, start a sprint, and also complete the sprint. Each member who participates in the project can update their progress on their assigned tasks every day, which we named it Daily Scrum. This allows the project owner to easily track the individual performance on their own assigned tasks. In this project, we have 12 members in our team, our project CEO, Kim, who is also our tutor, 5 developers, Joe, Teddy, David, Wendy, and Hannah, 4 DevOps, Leo, James, Jack, and Shelton, 1 UI designer, Xiaoxing, and 1 business analyst, Belinda. For the tech stacks we have implemented in this project, in the front end, we use React for fast rendering, TypeScript for early bug detection, increase predictability and readability of code. We use Context API for global state management and webhook drilling. Reusable and maintainable source is used to style React components. Axial is used to communicate front-end with back-end API, and we also use Cypress for testing. For backend, we use Node.js, TypeScript, Express, and MongoDB. In order to record abnormal behavior, Wisdom is used. And we also use SES for email verification, Jest and MongoDB memory service for backend testing, and for Postman for testing and debugging RESTful APIs. Considering our target customers are different enterprises, each company should have its own project data. So for maintenance, data isolation, and scaling purposes, we use SaaS to build our backend. Basically, each user will have their own database. We also use Git for version control and Bitbucket for Team Git repository collaboration. So next, I will pass the presentation to our project leader, David, and he will show you our project's demonstration. Thank you.
Thank you, Hannah, for introducing the product. I'm David. I'm the leader of the developer team. It's a great honor to demonstrate you our TechScrum application. Here comes the fun part. So first of all, this is our homepage. We have developed some fancy animation to entertain our user. We also have feature highlights, what this application can solve. And this is our team member information. We also have a career page for anyone that might be interested to join us. Also, the user can book a demo with us by filling in their information. Now let's log in. After the user has logged in, he will be directed to the project page where he can see all the projects. Let's click one of them to have a look what we have in there. So we've got a lot of cards in our board. We have 4 categories. And let's say I'm working on this card, I can move it to in progress. If I'm done with this card, I can move it to done. The user can also create a card, fill in the title, and then pick a card type and click create. Now a new card has been created. If the user click the card, a modal will pop up. The user can edit the card here. I can assign to Kidman. And now the assignee should be Kidman. I can also pick existing label or create a new label by typing. Then I close the modal. Now the label has been updated for this card. The user can also add comment in this modal and click publish. Now a new comment has been added below. The user can also view the activities of this card or delete this card. Now, as you can see, the card has been deleted. The user can also search the card in the search bar. Now let's have a look at our backlog page. Backlog shares the same card with the board. In the backlog, the user can create a card of different type. So let's try to create a new issue. Select bug. And after typing the card name, press enter. Now a new card has been created. The user can click the edit icon to edit the card title. Then press enter. The card title has been updated. The user can change the priority, change the status, and also assign this card to one of our members by typing the name. The user can also delete a card. One important function backlog has is sprint. The user can create a sprint, first give it a name, then set the duration to 1 week, for example, and then pick a random date. Now the end date will be automatically filled. Now click create, and the sprint is created. The user can either create issue in the sprint or add issues from the backlog to the sprint. Now let's try to create an issue in the sprint. Now let's try to move an issue into the sprint from the backlog. The user can also start a sprint. And once the user clicks start, the sprint that started will be the current sprint and stay at the top. And the user can choose to complete that sprint. And upon completing, the sprint will be removed from the backlog along with all the tasks. The user can also edit the sprint, change the name and pick a new date and click update. Now notice that the sprint name and the date has been changed. The user can also delete a sprint. And all the tasks in the sprint will be gone as well. Another important function we have developed is daily scrum, where the user can update their progress on their assigned task. Now let's try to create a new card first. After the card is created, we can click open it and then assign to myself, which I'm logged in as Kidman, so I'll assign to Kidman. Yep, and then click daily scrum. Now I should be able to see the card just assigned to me. And then I'm required to report my progress and then click submit. And after submission, I can click daily scrum again to view my submission and make update if needed. So every team member are required to do this every day for the team leader to track their performance. So that is the end of the demonstration. I'll hand over to Jack to introduce you the DevOps part.
Thank you, David. I will continue the introduction of architecture, CI/CD, and monitoring for our project. We involved a 3-tier architecture for our website. First, Route 53 will route traffic to CloudFront for our front end, and CloudFront will speed up content delivery and decrease latency. For our front-end static website, we use an S3 bucket to store our code and resources. Our backend was deployed to ECS Fargate. We have 2 Fargate containers in 2 availability zones. The application load balancer can isolate HTTP requests into 2 containers, and because our backend is not accessible to the public, the containers can only accept inbound traffic from application load balancer. To respond to our users, we deploy a NAT gateway in a public subnet and connect it to 2 private subnets, allowing outbound traffic and can go through and send responses back to users. The backend was also subjected to an auto-scaling group. Our desired task count is 2, and when the CPU utilization reaches 60%, a new container is automatically added to match the increased load. Since the auto-scaling group is free and we only pay for the resources created underneath, and it is a more cost-efficient method. In addition, for the database layer, we utilize MongoDB, a NoSQL database program, and we intend to create multiple database backups in different regions for disaster recovery. Then we will get into our CI/CD. We choose AWS Code Pipeline as our CI/CD tool. For the front end, it will install packages, test the code, build artifacts, and upload them to S3 bucket. For the back end, the code pipeline will dockerize the backend code and build the Docker image, then push the image to AWS ECR. And the ECS tasks will use the new build image to deploy our backend. To prevent data leaks, we store our AWS credentials and environment variables in AWS Secret Manager. We have 2 environments as shown in the diagram, development and production. Both environment pipelines are automatically triggered when new codes are merged to a specific repo branch. We also incorporated the GitOps operational framework into our workflow. The Terraform code pipeline will automatically deploy resources in each environment account, maintaining our single source of truth. Furthermore, as our remote backup, we use 2 separate S3 buckets in each account to store our Terraform state files for each environment for our team members to use. Our Terraform structure is shown in the diagram. Modules composed of each component to be reused later. For monitoring, we follow 4 golden signals: latency, traffic, errors, and saturation. AWS CloudWatch will gather the necessary metrics and monitor performance with AWS Managed Grafana. We also set an alert for when the ECS task CPU and memory utilization exceeds 70%, indicating that our containers are not healthy and we ought to take action. And that's all for the DevOps part. Now I'll hand back to David. Thank you.
Thank you, James. Our members work as an agile team using Jira. In the beginning, our business analyst, tutor, DevOps team leader, and developer team leader had a discussion in regard to whole project planning and task allocation. After that, the DevOps team leader and the developer team leader allocated tasks every week. BA held stand-up meetings every night, and each team member needs to report their progress during the meeting. Our sprint duration is 1 week, and each sprint is closed on Wednesday. Upon closing the sprint, a retrospective meeting is scheduled to review the sprint and think of future improvements. Over 3 months of agile development, we were able to communicate and collaborate efficiently. Delays had been reduced and features were delivered a lot quicker. As shown in this cumulative flow diagram, under our effective cooperation, we can see that our team had completed 85% of the features as we planned. Some features are still in progress and testing. and we will continue to add more features to create a better user experience. All of our team members put in a lot of effort during the development for this project, and everyone in our team always take ownership. Good job, everyone. Thank you all for the contribution. We also appreciate our tutor Kidman's help. He helped us to improve our hard and soft skills to a large extent. Lastly, I would like to thank JR Academy for this great opportunity to train our skills. Thank you all for listening.